Hello ladies and gentlemen, today we're going to be working on the second part of scientific notation. Let's look at our objective. Make sure you write it down in your spiral. Our objective says I will be able to convert a number in standard notation to scientific notation. And if you recall from yesterday, we went from a number in scientific notation to standard notation. But today we're going to be doing the reverse. We're going to be starting with standard notation and we're going to be going to scientific notation. And as you recall, standard notation is just the normal way we write a number, but scientific notation is a special way of writing a number where we multiply by a power of 10. So we're going to be again converting from a regular number to scientific. So here are our steps. Make sure you write these down in your spiral. It says, step 1, we're going to move our decimal until we have a single digit before the decimal. This new number is going to be A, and I showed you this yesterday. This is the way we write scientific notation. It's always a number A times 10 to a power. So the first step, I'm going to show you how do we get this number that's before the multiplication symbol. How do we get that letter A? So let me just give you an example as we go along. Let's say I had the number 230. That's written in standard decimal notation. Our decimal point is at the end of the number. So my first step would be to move that decimal until I have only one digit to the left of the decimal point. Okay, so right now, as it starts out, I have 3 numbers to the left. So I'd have to scoot it back once, twice. Now this new number, 2.3, would be where I put the letter A. Okay, so that's what I would have before the multiplication symbol. Okay, so let's move on to our next step. Now what we're going to do is we're going to count how many times you would have to move the decimal to get back to our original number. This is going to be our N. Our N, remember, is the power attached to the number 10. So let me go back to the number we had on the last slide, 230. So here was my decimal point and I moved it 2 places back and I got 2.3. Okay, so now I'm going to have 2.3 times 10. I'm going to count how many places I would have to move it to get it back to its original location. So to go back to its original location, I would have to move my decimal point 2 places. That would be my exponent. So that number now is written in scientific notation. Now this part in red down here is super important, so make sure you write this down. If you have to move the decimal to the left to get back to your original number, so if I had to move it back here to get to my original number, then the exponent's going to be negative. And guys, a lot of people have trouble with this whole right-left business. So I want to give you something to kind of help you determine if your exponent's going to be negative. If your original number, write this down, if your original number is less than 1 whole, your exponent is going to be negative. Okay, please write this down. If your original number was bigger than 1 whole, then your exponent will be positive. A lot of students have trouble with the left and the right, determining which way they moved the decimal point. So I like to use this instead to determine if I'll have a positive or negative exponent. Okay, so you're probably going to need to pause here so you can get all this good information written down, and then you can resume with me. We're going to do some examples. Okay, so we have 243 million, and I have my decimal point back here. First thing I'm going to do is I'm going to move that decimal point so that there's only 1 digit to the left. Right now I have 9 digits to the left. So I'm going to move it, and I'm going to keep on moving it until there's only 1 digit to the left of it. Bam, it's going to go right there. Okay, that number there is my A. So I have 2.43 and then a whole bunch of unnecessary zeros, so I'm not going to write those down. So I have 2.43 times 10 to the, okay, let's count how many times we moved that decimal point. We moved it 1, 2, 3, 4, 5, 6, 7, 8 times. So my exponent's going to be 8. Now, let's talk about if it's going to be a positive exponent or a negative exponent. Let me put the decimal back where it was to begin with. This original number was bigger than 1 whole, greater than 1 whole. Okay? Obviously, 240 million is bigger than 1 whole. So therefore, my exponent should be positive. There is my final answer. Okay, let's do another one. 0.00012. Okay, so I'm going to move it so that I only have 1 digit to the left of the decimal point. Right now, you can only have 1 digit to the left and it cannot be a 0. So right now I have 1 digit to the left, but it's a 0. So I'm going to have to move it again. Up, it's still zeros to the left. Still zeros to the left. Still zeros to the left. There we go. Okay, so remember, you can only have 1 digit to the left and it can't be a 0. So now this is going to be my A. Okay, let me just remind you something real quick that we talked about in the last video. The value of A has to be between 1 whole and 10, okay? It's got to be greater than or equal to 1 but less than 10. That's another way you can tell if your A is correct or not. Okay, now let's see how many times we moved that decimal point. We moved it 1, 2, 3, 4 times. Okay, our original number was a very, very teeny tiny number. Let me put the decimal back where it was. It was less than 1 whole. So therefore my exponent should be negative. Okay, so 1.2 times 10 to the negative 4th. Okay guys, now I have some for you to try on your own. Both of these, I've got one of them that's going to have a positive exponent, one that's going to have a negative exponent. You're going to have to determine which one is which.